For those of you online, this next session, as you can see in the agenda here, we're going to spend about an hour working through a Tiltwing concept. So while we're doing that, we are just going to build it up. It's going to be based on the NASA UAM reference vehicles. So while I have this, let me just pull that up and show you all what that looks like. So here we have our web page for the
You're
NASA
not
reference.
sharing yet, Brandon.
Well, I'm sharing it on the stream. I'm not sharing it to the teams. I'll switch that up
Oh,
so that
sorry.
you can see what I'm doing. Just a sec. Hopefully it doesn't freak out if I'm doing two things at once. But okay. So here we go. We've got some of our 6-passenger UAM reference vehicles, tilt duck, tilt wing, tilt rotor, lots of stuff. The nice thing about each of these is that they come with the documentation, or essentially the white paper that was published sizing each of these aircraft. You've got in-dark models and the OpenVSP models for all of them. So if you want to go in and pull down one of these NASA OpenVSP models, they're released. You can start there, play around with them, and turn them into your own thing. So with that in mind, I saw that there are some new folks joining in and joining the chat. Thank you all very much for tuning in. Welcome. If you haven't been there yet, I wanted to point out to everyone that the OpenVSP Ground School is still up and running, and it's vspu.lark.nasa.gov, and I posted a link there in the chat. That's where you can go and visit this if you want. When you land here, there are lots and lots and lots of tutorials, and anyone that's revisiting that's seen these before is probably getting sick and tired of hearing my voice, but one that I like to point people to is this introduction to the basic modeling process. And so each one of these tutorials, if you click on it, it will show you where you are in the training library. It has a brief introduction and then a short YouTube video walking you through that individual step. So what we're going to do is go through this live by essentially building an aircraft on the fly. Now, as is historic with OpenVSP demos, something may go wrong and it'll crash, so I'll save often. But for the meantime, I'm going to go ahead and minimize this and bring up OpenVSP so we can go ahead and get started. So let me resize some of my screen so that everything looks pretty good here, and then we'll start playing around with this. Bring that out to about here. That looks about right. Okay, so from here, we're going to go ahead and build an aircraft. Now, the great thing about OpenVSP is this doesn't take very long at all. So all we have to do is, like Rob said, define what's the mission, what's the point of it. Well, in this case, our point is to carry about 6 passengers. So the first thing that we need to do is add some passengers. So there is a handy little human geometry here. And if I fit this to my screen, it's a wireframe mesh. There are presentations at previous OpenVSP workshops that go into exactly how this thing is built and manipulated, but it's a really handy feature. So for starters, we're going to change it from a standing to a sitting pose. All right. And based on what we have on defaults here, this is just a regular, certain age percentage male body in a mesh format. So what we're going to do is I'm going to make 2 of them side by side by turning on our XZ symmetry about its own reference, and I'm going to separate them a little bit with this slider here. And so I think about 1 foot or so away from center line is good. They might rub elbows a little bit, but that's not really a big deal. Okay, so now that we have that, let's go ahead and make another row. Now in this case, I can just copy, paste. You can see here that this is now what's called a child of this ancestor. So they're right on top of each other, but if I move them aft, here we go, we've got our second row. So now we have 4 passengers. I'm going to set this to about 2.5, give everybody a little bit of knee room. And now I'm going to attach this to the parent. So in this case, I'm going to turn on component translation here. Okay, now notice that it shifted based on this 1 unit to the right. That wasn't really what we intended. We're going to get rid of this Y separation. But then where did our second person go? That's because our symmetry is about itself. We need to go and make it about, or I'm sorry, it needs to be about itself, not its ancestor. So here we are. We've got our second row of passengers. So all we're going to do is repeat this process, copy them, paste another row. Again, we need to change that ancestor right here. And now we've got our 3 rows and our 6 passengers. Excellent. So while I'm at it, if we come in here, there's a fast way to just change this from a male to a female representative body. We can come into pose. We're going to change some of this elbow angle to try and bring the arms in just a little bit. Okay, so now we have our passengers. So anyone that has used OpenVSP for a while knows that if things are going to go wrong, we need to save, because there is no autosave in OpenVSP. So what we will do here is we are just going to save as Tiltwing Demo 1. Okay. Now we have a backup, and if everything crashes, we can just open it back up and get back to it. Okay. So the next thing that we're going to do is we're going to add a fuselage to carry these people. Okay, so we're going to add that in. By default, this is about 30 feet long or so, clearly the wrong shape for what we need. So under our design tab, we can change the length, we can move things around. But what we really need to do is put this around these people. So just for starters, I'm going to move it forward to about here, I think. That might even be a little bit too far. Let's back it up about 6 feet or so. And then in the design tab, let's set this to something like, 25 feet instead of 30 feet. And even then, that might be a little bit big, but we'll see how it goes. So as we're doing this, we need to adjust these cross sections inside. So right now, the tip is a point. We come out to the next cross section, and here, that's essentially this cross section. So we can adjust the width, you can see here from the front, and we can adjust the height, because right now we're set to an elliptical cross section. So an ellipse is a fair place to start. We could change the shape of this, and we probably will later, but for right now, let's stick with that. So instead of having it sit right there, let's nudge it forward a little bit, put it right underneath that front row feet, and we'll set this to something like 6 feet tall, and we're not too bad on the width, but let's make it, say, 5.5. Okay. So instead of having to go through that whole process again, I'm going to copy this and just paste it at the next cross section. All right, so now we have something resembling a cabin. That cross section again is probably a little bit too far aft. We're going to bring it forward. And now we're starting to get something representative of a shape. So in the next cross section, we can move that around all the way back if we want to, and we can start to shape this stuff. So while we're at it, let's go ahead and make this a circle. We're going to change the diameter so that it's a bit more like a tail, maybe something like 1 foot or so. We don't have to be really fancy with it. And then what we're going to do now is we're going to shift this up. We want to have something that's a bit more of a flat shape here on top. Now don't worry about that weird little ghost tail at the back. We're going to fix that too. Let's make this about 1.5. That seems about right. So back here at this closeout point, all we need to do now is set that Z to match about 1.5. Okay, no big deal there. Why don't we go ahead and nudge this a little bit more? Okay, so now we have something kind of resembling a fuselage to carry these people around. We can refine this a little bit if we want to play with some of the cross sections, maybe dip this nose down some. All right, no problem there. Let's make it a little blunt. Now, in skinning, for anyone that hasn't tested the modeling yet, let me go to a nice side view so you can all see what I'm doing. So in skinning, you're effectively changing the strengths and angles of how the curve flows through each one of these cross sections. So I'll give a brief demonstration here. top side of this 0 section, you can see is set to 45 degrees, and it's moving up. If I bring that down, it makes it more acute. If I make it bigger, it increases the angle. Now, we have top-bottom symmetry turned on at the moment, and that's fine. We also have left-right symmetry turned on. If we turn that off, we can adjust the bottom independent of the top section of that curve. So for now, I want to set both of these to 90 because I want kind of a blunt nose on this thing. But I think the strength is a little bit too much, so we're going to dial that back. Maybe something like 0.3 is fine down there. And 0.3, nope, not 3, 0.3 is about right there. Okay, so same thing here. We're going to do 90. Now, even though the front of this still looks faceted and kind of sharp, you can see the curve is smooth. So if I come in to our section, come back here to 1, I can increase the number of view panels between this section and the previous one, and we can make that smoother. So I can give this any number I like. That seems fine, but you can see we get a reasonable, smooth front end to this fuselage. If we want to make it a little smoother on the way around, we're talking about num W. So we can increase the resolution as we go around. There we go. So now we've got a fuselage to carry these people around. If we wanted, we could go in and change some of the shapes of the cross sections. We can refine this a little bit. And maybe we'll do that a little bit later. But for now, let's move on to some other components. We know that if we happen to move this, we want the humans to move with it. And with recent additions to OpenVSP, we have the ability to change around the hierarchy inside this tree that we have. So really, we want the fuselage to kind of be our beginning. And now we want the humans and everything underneath to be children of that. So the first thing I'm going to do is save this model in case things go wrong. And then I'm going to nudge them inside. So you notice I pushed this button. It made that component a child of the fuselage. And now they're all matched. Now, if I want these individuals to move along with the fuselage, I need to attach them. So in this case, we're going to attach it to the component, but you notice that it shifted everybody forward. That wasn't really what we wanted it to do. So if we come back to none, now we can click absolute coordinates, then attach in both translate and rotate. Now we can come back and turn relative back on. So that keeps them locked in their current position. You can change the attachment, and then they stay in position when you reattach them to everything else. So if I were to come in here and now move around this, oops, sorry, wrong one. So if I come into the fuselage and pick the right component, I can play around with this, and now the humans move along with it. So we'll just set that back to -6. The other thing that we can do, say we want to roll things around. Now, you notice that the front row is rotating along with the body, but only the others are rotating as well. That's because they are not set to rotate with the component. We need to fix that. So here, again, we're going to absolute, turn on component rotation, come back to relative, absolute, turn on component rotation, back to relative. Now, if we rotate around, you can see that everybody moves along with this body. So if you're trying to change the orientation of your vehicle, you're trying to move things around, do collision detection, stuff like that, it's important that the stuff inside the component moves along with it. So now that we have that set up, now we can move on to the wing. So here in our geometry browser, we're going to pick the wing component. Again, we'll make it a child of the fuselage. We can add it. So here we go. We've got the fuselage geometry. The wing is down here, and it's just dropped it in space. Okay, so for something about this size, we need to adjust the plan form. We can do that either under the Plan tab, where we're changing the overall wing shape, or we can come in and adjust it by section. So if we jump to a top view here, let's change the span to something like 40. Well, maybe 45. Let's make it a little bigger. And then we can come in and start to play around with some of these other features. So let's make, now we can leave the root chord at 4. Let's change the tip chord to something like 2.3. 30 degrees is an awful lot of sweep for this. Let's change that to something like 5. That seems a bit more reasonable. We can give it some extra sections if we want to, but for the purposes of this demo, that's not really necessary. And now that I look at it, maybe that was a little big. We'll do 3.5 down at the root. Okay, so we're starting to get something that's a reasonable shape. Now, if you remember from Rob's discussion, there's a reason to size all these a certain way. In this example, we're just putting stuff together and essentially making a cartoon aircraft. I'm basing the numbers of these dimensions on the white paper that I referenced earlier. So the sizing, the decisions that went into every single one of these was already made. But before we make a real educated guess into how to put these things together, how big that wing actually needs to be, the analysis should be performed so that you know you have enough wing area to actually pull this off. So anybody that's curious about why I'm picking the numbers that I am, go look at the white paper, the tech memo on the Tiltwing aircraft, and you'll see where I got these numbers. So now we have our wing. Again, it's not really attached to anything, but we can turn it on, say component in both translation and rotation. We're going to move it back to about there. Call it 6 feet aft, and we're going to move it up to the top of the aircraft. So this will be a little easier to see if we do a left-hand view. Nudge this up about there. Not too bad. So we haven't changed the airfoil, we haven't changed the thickness, we've done none of that, but that's okay. Now remember, for this, we're making a tilt wing. So what we would like to do, we can set a hinge and make that control the rotation of this whole thing, or we can change the rotation itself. Now, if we just come back and start playing around with the Y rotation, you notice it rotates at the leading edge. If I zoom in a bit, it'll make it a bit more clear. So it's rotating essentially at the 0x relative to the airfoil. We can change that position anywhere from 0 to 1 along this section. So now if I start to rotate, you can see it rotates about the trailing edge. So without yet going into a bunch of steps to try and make a hinge and everything else, we can just set this to something like 0.7. Let's assume that we have a spar back there. And now the wing can rotate. And if you notice, as I'm coming up against this button here, it's changing from an inside arrow to an outside arrow. Anyone that hasn't seen this behavior before, if you click on this, it increases the range of the slider. So now we can go all the way up to 90 degrees or beyond and rotate down. So we can go as far or as short as we want. If you find that that range is too big, simply click on the collapse button and that will shorten the range. Now we have a smaller segment that we walk through. All right, so now we've got our wing, we've got a fuselage, we've got some people in it. Let's go ahead and save again to make sure that we don't crash anything out. And we are going to add some propellers. So let's do that next. In order for this to take off vertically, of course, it has to have rotors. So we're going to grab a prop component, and we're going to add that under the wing. Okay, so our default propeller is 30 units in its diameter. That's far too big for what we're doing here. So I think what we'll do is set this to something closer to 7.3, something like that. And we can make this a 5-bladed rotor. And if we have time, which it looks like we probably will, we'll come back and maybe play around with some of the blade curves and give you some demonstrations of that. Now, again, this isn't attached to anything. So we need to put this on the wing. So right now, we've got people, we've got a fuselage, we have a wing. Things are starting to get a little bit more complicated. Just as a general demonstration, under the General tab, if we want to change the color of the fuselage wireframe, we can choose any of these colors here. We can also shade it under any of the default materials, or you can make a custom material. So for this, let's go ahead and call the material a nice medium darkness glass. and we can shade this fuselage. Now we can see inside it. The people, if we want to select the human geom or use this button to collapse the whole list down, we can hide them or show them. We can also change the color, of course. But for now, let's just hide them away. We know they're there, but we don't need to see them at the moment. So for our propeller, instead of attaching in component, what we really want to do is attach it to a certain position on the wing. Now we can do this a number of different ways. There are other presentations where we talk about attachment and rotation with parent and child in the ground school. For here, we're probably just going to set this to something like eta. So now, down here, we can set this as a function of essentially the span or the semi-span. Now, if we would have had, say, a multi-section wing, the U parameter gets broken up where all the way down here at the root, and by the U coordinate, I just mean the surface that represents the outside of this wing. So down here at this line along the chord at the root is U0. And then because this is essentially a one-section wing, this is 1 or 1/3, 2/3 is all the way out here at the tip, and then 3/3 is the end. So if you happen to have your coordinates based in something like UW, if you split the wing, all of a sudden that U coordinate changes. The eta parameter lets you place it along the wing and it stays fixed. So notice how all these are updating. So what we want to do is we're going to attach it out to essentially the wingtip, okay? And we want this to be all the way forward. Now it's attached at the leading edge of the wingtip, but notice it's still not quite rotated where we want it to be. Let's put the wing back to 0, just so that we have everything in the position that we want it to be. We're going to take the propeller, let's move it forward, say 1.5, and let's move it down just a little bit, so 0.5. That should give us just enough room for a nacelle out there. All right, so we jump to a front view. We can kind of see where this rotor is going to live. In this case, now we want to attach it to the component rotation. We want it to move with it. So I've activated the rotation. Notice that because it wasn't rotated at all, it didn't move, it didn't do anything. But what should happen now is if I change our rotation, now our propeller moves. So I can rotate this around, and the propeller rotates along with the wing just like it should. All right, so that was a successful addition of a prop. If we want one on the other side, you can either add a completely unique prop component over to the other side and repeat the process that we just did, or you can just turn on symmetry. Again, it's symmetric about itself at the moment. We want it to be symmetric about the wing or its ancestor. So now it popped it over to the other side. Symmetry applies to both the geometry itself and the direction of rotation. So if I zoom in, and you can see here at the wingtip, this propeller is made to turn essentially outboard down. So it's turning this way. We go and have a look at the other side. The blades are all reversed, and it is turning opposite. It is turning outboard down on the left side. If you have propellers where you want them both rotating the same direction, symmetry will not work for you. You have to create a new propeller geometry out on the other side and turn it. So now that we have that placed, let's go ahead and save before this decides to crash on me. We're going to copy, and we're going to paste. Okay, so same thing. All we're going to do now is change this eta parameter. Now as we move this in, we're just nudging it a little bit further inboard. Let's put this at, say, eta 0.65. All right, and now we're going to copy again and paste a third. So instead of 0.65, let's make this, no, that's not quite right. Let's do 0.3 maybe. Okay. So those seem spaced fairly evenly, and I don't think we're going to hit the fuselage, but a nice way to check. If we come to the design tab in the prop mode, we can go from blades to disc, and then let's have a look at it from the front. Okay, we've got plenty of clearance, no problem. There are other features in OpenVSP that will let you check these distances and make sure that you're not hitting anything, but for just this quick demonstration that we have, this should be fine. So we have our model, and for the sake of having things speed up just a little bit, I'm going to change all of these to disk. So now we can see where everything is. And note that because I have them attached to the leading edge of this wing, jump to a top view and zoom in, there is already a 5-degree stagger assigned to these. So if I come into the wing, and since we're on the subject of attachment, the reason that I attached it where I did, and you can think about this as a way to easily manipulate a model. Say you set everything up the way you thought it was supposed to be, but now you want to do trade studies on it. Rather than having to go in and individually manipulate each one of these variables for every single component, you have intelligently set these up with the design intent already there. So let's say, instead, I want to come to this section and instead of 5 degrees of sweep, I want to increase that to something closer to 10. The propellers, everything that is attached to that specific surface is moving along with it. It moves along with it. That's very important because if you come in and you want to change one thing, everything else is going to automatically update. Similarly, if we wanted to give this some dihedral, the rotors move. So we could give this some anhedral, we can do whatever we want. So just for fun, we'll give it a little bit of anhedral. That's not in the actual model, but we'll do it just for the heck of it. Okay, so now we've got our wing, our prop rotors, our people. We're working our way towards a reasonable aircraft here. So what we'll do next is we're going to add a vertical tail down at the back. In this case, we're going to start with a wing component, add that in, but because we don't need a reflective copy across the center line, under the transform tab, we're going to turn off the XZ symmetry. And we're going to rotate this about its x-axis by 90 degrees. So now we have a wing that's turned 90 degrees, and we've got a vertical tail. So again, I could just move this thing in space, set it back where I want it to be, and leave it there. But if I start to go play around with, say, the fuselage length or how everything is shaped, that tail's just going to sit there and it's going to be in the wrong spot. So this is how we address that. In this case, let's go ahead and change the name of this wing geom to vertical. So you'll notice that all I had to do was type a new name here and it updated the component. You can also do this under the name button here for any component. So again, this is wing, these are propellers, humans, or fuselage. But we changed the name of our vertical. In its tab, we're going to go ahead and move it about back where we want it to be. Say, here-ish. We're going to come up a little bit, put it about in the middle of the fuselage tail there. Now we're going to change our span to something a bit more reasonable. Call it, say, 4.5 feet. Why not? Okay, so it's still pretty big down here at the root. We don't necessarily need that much. Let's set that something like 3 seems reasonable. Okay, so let's shift this around a little bit more. Call it a square 15 feet. All right. So now, again, we can turn absolute on. It's a child of the fuselage geometry. Instead of attaching it just in component, we can attach it in UW or RST element. These are different kinds of coordinates that are inside the body itself. Because I really want it in reference to this trailing edge point on the fuselage, I'm going to use UW for translation and component for rotation. Now my attachment point here, I want it to be all the way at the back. So I'm going to set this at 1. Notice here, this little dashed coordinate system tells you where the parent or the origin of this component is. So if I walk this back, you can see it's walking along that line and just going along the fuselage. So while we're at it, let me jump to a top view and we'll do just a quick overview of what UW space looks like here. So U, we're going the length of this body. W, we're essentially going around the body. So it starts on the right-hand side, goes all the way around, 0.5 is left, it goes around the bottom, top, and over to the other side. In our case, because we're attaching all the way at the end, it doesn't really matter. But now our attachment point is back here. Great. So now we can come back and turn relative back on. Everything should be attached. And again, if I come up to the fuselage geometry and start to play with it, everything should rotate and move, and it does. Set that back to 0. Good. So again, if I wanted to come in and play around with this geometry, let's go to the fuselage and say, instead of a 25-foot length, now I wanted to make it a little bit longer because I was wrong. Again, the tail is moving. Now you notice that the wing isn't, because the wing is only attached to the component. If we want it to move relative to the body and stay attached in that position, we need to do something a little bit different. So here we're going to set that to 25. Let's come back to the wing and think, what can we do to force it to stay attached to that point? So here it is. Instead of component, we can do UW, or we can switch to volumetric coordinates. So in this case, let's set it to an RST attachment. And now we're going to switch back to relative. So what should happen now, if I come into the fuselage and now start to play around, oh, I picked the wrong component. That was my mistake. So unfortunately, sometimes I go off on a tangent and you guys get to come along for the ride. So we're just kind of doing our thing. That's weird. Oh, I see why it's mad. Okay. In this case, I messed up and didn't attach it where I needed to. There we go. So now I've moved the coordinate here closer to where it needs to be on the fuselage itself. Now if I go back to relative, things should work. There we go. Okay. Moving on. So now we have our props, our people, our wing, fuselage, a tail. Again, we're going to save in case this thing crashes out on me. So we're going to add a horizontal tail. Again, we're going to add a wing component. We're going to make it a child of the vertical tail because we want the tails to stay together. Wow, I am sorry for whatever is going on out in the hallway, everybody. Again, we're going to change the name, horizontal tail, and we're going to attach this again in UW. Let's go ahead and set the W to 0.5, which is the leading edge of this geometry here. And then we can set U all the way out to 1. So that'll bring us out to where we're attached here at the leading edge of the tail. We can probably have a little bit more here at the tip of the vertical. Let's adjust that while we're at it here in the section tab. Make that 2. Sure, why not? So because I want those to be essentially equal, I'm going to make my root 2 and my tip 2. And I'm going to set sweep to something else. Let's say 0. Now, that's a little bit too Hershey bar for my liking. So why don't we change this? Let's first move the secondary sweep location off of 1, because you can't have sweep and secondary sweep to be equal. We're going to set the sweep location back to the trailing edge at 1, and we're going to leave sweep at 0. Now, if we adjust our tip cord down a little bit, notice that it's keeping that trailing edge straight, and it's just moving the cord so that it shrinks it back a little bit. So I think that looks a little bit better. We'll do maybe 1.5 out here. Too big of a span, though. So we're going to do something like, yeah, I guess that's actually okay. Let's do 8. Why not? Okay. So relative to these other components, we've got our tails. Let's take a nice front view. In this case, we know that we're going to want to have some prop rotors here at the back that are going to, one, provide some extra thrust, but we also need some stabilizing lift in the back. So once again, we need to come back and add some prop rotors to this thing. So at the moment, let's take one of our propeller geometries here, copy that, and we're going to paste it onto the horizontal component as a child. And because it inherited the attachment properties of its parent, you'll notice that here in the transform tab, it's already got symmetry, it's attached to its parent, and it's already referenced in eta all the way out to the wingtip. And it's got the same X and Z differences here. Okay, so we're not hitting anything. Everything is kind of where it needs to be. Great. But let's assume that the horizontal tail doesn't tilt the way the main wing does. So if we wanted to rotate these, let's have a look at what happens. If we just rotated the propellers all the way back to 90, well, we hit our tail. That's not what we want to do. So there's a way to go about this. Let's set this back to 0. And now we're going to do a hinge geometry, or a hinge component. Instead of leaving the propeller geometry right there where it is, let's come to the horizontal tail. We're going to pick a hinge, and we're going to add that to it. Okay? So a hinge geometry is a handy little feature that acts as either a slider, a rotating component, an axis. You can do all sorts of stuff with this, but for this, we're going to make it a simple rotating component. So here, we're going to choose to place it relative to the horizontal tail. We can place this either in component, we can put it wherever we like. In this case, let's attach it to the tail. We're going to make it in reference to the wingtip. We're going to bring it all the way forward. And now let's say we want this rotation to occur somewhere forward and slightly above where we are now. So some of the relative displacement, we're going to come back, say 6 inches, and we're going to go up about 6 inches, let's say. Or actually, you know what? That would probably work fine, kind of as it is. Let's leave it there. Now that we have this geometry, we need to pick a direction. So instead of using the transform tab, we're going to use the vectors. And in this case, we want to rotate about the y-axis. That's going to be this green line we have here on the screen. And positive rotation is in the direction of this arrow. Okay. So we could just leave it as is. We can choose a vector. And here, notice that everything has turned. We've got rotation of y equals 1. Good. But if we come into the motion tab, moving this around doesn't do anything. Nothing's attached to it. The nice thing about the way OpenVSP now handles parent-child relationships is we can come into this prop, again, turn it back to absolute coordinates so it doesn't move relative to everything else on the space. And now we can nudge it down in the hierarchy, and we can make it a parent of the hinge geometry. So notice that because the parent changed, the symmetry went away. We just need to fix that by making it, again, about the horizontal tail. Okay? So everything now should be set up. And notice that all of the options that I had set for this propeller component got turned off. Anything that becomes a child of a hinge geometry automatically gets attached to it. It's its sole purpose. You don't have the option. But what should happen now is if we come to the hinge component and we go into motion, we can move these around. And so a hinge is a very, very versatile component in OpenVSP. Let's say we want to constrain the range. So we activate these buttons. Let's set our minimum to something like 0. Okay. So we can set that. And then for the maximum, we want to set it to something else. So let's move this up to, say, 90. That's where we want it. Great. So instead of having to type this in twice, I can click the set button. What that does is it takes the current value of rotate and assigns it. So here I can bang around it. Look, there's all this range here in rotate that I'm not using. So that's not very useful. Let's click on range. Now the min-max of this range is set to the min-max that we have here. We can go from 0 to 90 in one sweep. And again, anything that we attach to these is going to rotate just the same. So that was a little demo of a hinge component. Again, we're going to save. So now we have an aircraft that is carrying 6 people. Assume we've got some other components down inside. The wing itself, if we come to transform, we can do our rotation about our 70% chord location. Now notice, it's not like a hinge. I can over-rotate, I can do all sorts of stuff with this that I don't intend to. That's why it'd be much better to have this as a hinge, and everything else can be a child of it. You can change one parameter, and then everything updates the way that you intend to. So, in this case, if we did something like, well, let's set the wing tilt to something like 60, and we want our hinge here to set these at 60. Now we can adjust where these discs go, how they're pointing, how everything moves. And again, because we have everything attached, let's say if we came back to the horizontal and decided that we wanted to change the span, the rotors move with it. Everything moves, attachment still works, everything still does exactly what it's supposed to do. So in this case, let's set this down to something like 10. I like that better. There we go. So a nice 10-foot span, everything lined up. Now, one of the things we might want to watch out for, if we set our rotation of the prop rotors back to 0, all right, set our wing back to 0 in our transform tab. If we're looking at it from the front, the prop rotors in the back, which are, trying to either provide thrust, they're trying to lift, they're doing other things, are going to be influenced by these 2 rotors in the front. So they need to be offset a little bit. So there's a number of ways that you can address this. You can either try not to disrupt the flow with the inboard rotors by spinning them very slowly, putting them into a low torque scenario. You can do all sorts of stuff. You could give yourself a bit more anhedral on this side, and you could even come into the horizontal tail, say, well, if we want them to move up, let's just move them up. No big deal. So there are a number of ways that you can try and address this problem, but note that all you have to do in OpenVSP is come in and change 1 or 2 parameters, and it changes everything for you if you set up your model correctly. Now, if I didn't have this set up with all the attachment and everything that went in under the design intent, it'd be a mess. I'd have to move all this stuff manually. It'd be terrible. So a lot of the power of OpenVSP comes from the ability to attach and put design intent within the model itself so that you can go around and change things up. I see that we're getting about 10 minutes past the hour here. I've got about 20 minutes left. So essentially in about 40 minutes, we could cut some of that time off, accounting for some of my little screw-ups that I had. We've put together a reasonable representation of a Tiltwing aircraft carrying 6 people based on the NASA publication. So let's take some time and try and refine this a little bit. Let's save it, again, just in case something goes wrong. And let me, while I've got a nice little stopping point here, go back and see if there are any specific questions. A lot of activity in the chat.
We've been having a great chat, Brandon, but no real questions have come up about your model.
Perfect. Okay. Thanks, Rob. Appreciate it. So what we can do now is maybe move away from these elliptical cross sections and give it a little bit different shape. So let's start with the fuselage. Let's come back to our wireframe view, and let's start to adjust some of this stuff. So maybe we think that our people are a little too high in that fuselage, and we want to get them away from some of that structure. Okay? Well, the first thing that we'll want to do is set them a little bit lower. Let's go to a left-hand view, bring them down just a little bit. Okay, maybe something like that. So now, unfortunately, we've got some feet sticking out down here at the bottom. So again, if we had a shaded view, it's pretty easy to see on both of these. Let's shade both. So, okay, yep, we've got feet and toes sticking out the bottom of the fuselage. That's no good. So let's go ahead and adjust this cross section on the fuselage, cross section 1, and we're going to change it to something different. We could do a rounded rectangle, so we pop that in there. It's got a default setting for the rounded corners. All the feet are inside, great, but that's kind of boxy. That might not really be what we're looking for. Maybe we adjust the radius a little bit. Okay, not so bad, but it might be a little bit straight-sided. We can do a little bit better, I think. So instead of a rounded rectangle, let's go to a general fuselage section. Again, it reverts back to an ellipse. That's totally fine. But we're going to play around with some of these tangent strengths. So you're getting a little bit of a demo into cross sections and how to manipulate them in OpenVSP, but it's relevant to the problem that we have, because we have a lot of room here on the side to try and account for where these toes and the feet and everybody are. We don't need that. So let's cut back on the size of this fuselage. If we come down to our bottom strength, you can see that that's just pushing this out some. We can also push out from the lower side. So here we've pushed out maybe a little bit farther than we really needed to. Let's change this to maybe 1 and change our bottom to 1. That wasn't quite enough. Let's push this out a little bit more. Great. So if we set something like 1.5, that's a little better. Great. So on the top, we can either leave it as is, we can make it a little bit more boxy, but it's probably okay for what we're trying to do, because we really just want to leave room for the feet, bring this in a little bit, and then have a nice shape to give everybody some headroom. So we can probably dial our width back a little bit to something like that. And again, it doesn't look like anyone's feet are actually touching. There's another handy little trick if we want to do a fun feature. So let's go and check out Snap To. Now, this is one of those features that it's not really on the agenda today, but we can demonstrate it here. If we want to do a minimum distance, let's say we want to give them a little bit of clearance on their foot, somewhere in the neighborhood of a little over an inch, why not? If we were to take the width and drag this down, now we have the manual collision detection, and what this will do is it allows us to manipulate this variable until it hits something. So if we try and decrease the width, you can say, nope, can't do that. We've already got intersections back here. That's not what we want. But we can come back to this other cross section. In fact, why don't we just copy this one for the time being, paste it back here. So everybody should be inside. Now let's see if we can decrease. Don't want to play ball. That's fine. So we can't check clearance. It's saying that it's not touching. Anyway. So if we start to play around with these, we can adjust our settings. Let's go back to cross section 1. So we've been able to cut back on the width. You can see about right there, things poke through. So let's make this only about 5 feet wide. Seem to have some good clearance. Everything looks great. Wonderful. We can copy this, and since we picked 5 for the beginning, we'll pick 5 for this one. That may still be a little big, but we made something that's a bit more fuselage shaped. All right, so we got a little bit of refinement out there. Now we can come in and play around with the wing a little bit. So in the wing, by default, the airfoil that we've picked is just a simple NACA 4 series. In this case, it's a 10. If we want it to be something different, we have a whole list of different cross-section and airfoil types that we can pick from. Just for fun, we can set that to a 6 series. We can even pick what flavor of 6 series you like. So we can do something like a 64A, adjust the thickness to chord ratio up to something like, it's down here at the root. Let's make it kind of beefy for some structure, 0.15. Great. So we've adjusted that. We can again copy this, paste it out at the wingtip, but we don't need it to be quite as thick out there. So let's go down to, say, a 10% airfoil. Great. OpenVSP is taking that root airfoil that we set down here and interpolating the sections all the way out here to the end of the section at the wingtip. all of that stuff is taken care of for you. Another thing that we can play with that I alluded to at the beginning of this demonstration is that we can define what the blades themselves look like. So as an example, let's pick these inboard, change that back to blade mode. And here we have just a regular shape. Again, there's not a whole lot of wireframe density in this, but if we crank it up, there we start to get something that's a bit more representative of the shape that you see in the curve. You can back that down quite a lot. If we want, we can come to the blade tab, and here we have complete control over the chord, the twist, rake and sweep, skew, all sorts of stuff, the thickness distribution and the ideal lift coefficient. The prop component treats these as continuous curves as opposed to hard cross sections like you would get with a wing. So because we have a cross section or an airfoil that is an ellipse at the root, it turns into a 1/6 series right here at about 0.4 of the radius, and that 1/6 carries on out here at the tip, and it's very, very thin. You can see thickness scored is only 3%. We can adjust that. Let's say, for example, that our propeller needs to be a little bit stiffer out at the tip. We can change the thickness, and instead of a cubic Bezier, we can change it to either linear, a spline, cubic Bezier, or approximate a cubic Bezier if you do something like read endpoints. For now, let's change this to a spline, and we're going to want to adjust this. So instead of 0.3 out here at the tip, let's give it 8%. Why not? So we nudge that up. You can type the values in. You can also manually click and drag if you want. We can also delete a point. If that doesn't make any sense, we can just get rid of it. All right. So now you can see that as we're playing around with each of these, we have the ability to manipulate the model however we want. And the model is updating. Every time we let this go, it's bumping up and doing its thing. There we go. All right. So under cross-section, if we wanted to change that, again, we pick whatever airfoil we like. If we go back to the blade tab, let's say we wanted to change the twist distribution. Again, it's just a continuous curve. We can manipulate however we want. Same thing with the chord. Now chord here, move one of these, its adjacent control points move along with it. So the tangency is maintained however you move this thing around. And as I move it, as I let go, as I change things, the blade profile is updating. So I can shrink this down a little bit. Make it a little more rounded at the tip. Okay. So you get the idea. This is how you can come in and define your blade parameters. Now, it didn't update it for everything. It only updated it for that one. When you set up your model, if you want to link all this stuff together and make everything update based on a single parent or a single representative piece, you can do that. That's going to be a demonstration later in the week where we talk about links and advanced links, and we can show you more of how that works. But for the time being, let's just have an overall look at our Tiltwing aircraft. We'll give it all the resolution it needs. We'll have a look at our propellers in blade mode. All right. So again, here we've got a Tiltwing aircraft, 5 bladed rotors, 6 on the front, 2 in the back. Everything can be manipulated. Everything is able to be articulated. You can change and update the design parameters however you like on the fly. Nears makes no difference instantaneously. In traditional CAD, something like this would be a monumental effort without intentionally going in and putting the connections in yourself. OpenVSP does this stuff in a very user-friendly way, so that here, as we've just shown, in less than an hour, you can put together a fairly complex aircraft that articulates, moves, is sized based on any number of things. If you want to go in and change the design variables to be something like disc loading, thrust, your wing loading, what's your gross weight, all of that stuff can also be done. But you don't have to go in and change individual components and then rebuild everything and hope nothing broke. it all still works. They're all individual watertight geometries. This whole thing will mesh. The whole thing is closed. And so that is never really going to be a problem for you if you do things this way. So we've got about 7 minutes or so left here. And I hesitate to do it, but maybe it'd be kind of fun. Let's pop things back to a disk mode. Watch me crash it right here at the end after I spoke too soon and everything was looking really good. Yep, there it goes. Ha, I knew I'd get one. All right, well, we saved, so everything's fine. Here we go. All right, so first crash of the workshop. We got it out of the way. Great. Oh, it doesn't like that at all. Second crash. All right. Let's try this again. All right. So this will be a slightly different version of what we just made. This is one that I made ahead of time, just in case everything crashed. Lo and behold, it did. Great. So what we should be able to do now is play around with some of the analyses. Now, we don't really need the humans anywhere in here. That's fine. Let's go ahead and have a look at sets. Now, in this case, if we just pick set 0, let's say we want the fuselage, we want the wing, vertical tail, horizontal tail, and we want all of the propellers. Great. So if we were to come in and choose set 0 and show only, the people are gone, the hinge is gone, everything is where it should be. Cool. In any analysis, you can choose what set you want to look at. So in this case, instead of shown, we're going to use set 0. We don't bother with subsurfaces here, and we'll execute. So all this did was an intersected triangulated mesh on all of the components. You can see that the fuselage and the wing are stitched together. It clipped, it did the intersection, everything's good. And again, this is a watertight geometry. We can shade this, everything's put together, even the discs. Let's get rid of that, show only again. And if we do a quick look at what's the old version of VSP Aero now, if we choose that we want to play around with set 0, we can turn on our actuator discs. Okay, so everything is set to the defaults. Why not? We're going to do one run, leave everything effectively the same. Not going to play around with it. So let's just see what happens. This may not be a reasonable analysis, but let's launch the solver and see what happens. Okay, and we're done. So really quick analysis. We did no sweep. You've got CP distribution on your individual components. It shows you the convergence. But for the sake of the final bit of demonstration here, we can launch our viewer, which I'm going to bring up and show you here. So everything was included as a VLM. It collapsed the fuselage down to essentially a cruciform body. We've got some intersections in there that we probably shouldn't have. Okay, so I need to get rid of that and try this again. Let's launch viewer one more time. All right, it's popping up on my other screen. I'm going to do this here and then just pop up the display for you. Got rotors and nozzles. Okay, so I'm going to bring this up here. Good, it resized. So now we've got an aerodynamic solution. We've got our wakes. Everything's getting wrapped up. The rotors are displayed. It even indicates your turning direction. There will be more demonstrations of VSP Aero, especially the new features in VSP Aero this week. But for something like a Tiltwing, it's really easy to set up one of these analyses. Now again, you have to be careful, garbage in, garbage out with any analysis, but it's kind of made easy for you. That doesn't absolve you of responsibility. You still need to know what you're doing. But, I mean, what more could you ask for? This is pretty great. So we are coming up to about 12:30. That's going to be our first break of the day, I think. And then after that, we're going to come back with a presentation on three-dimensional cross-sections or three-dimensional backgrounds. So Rob, is there anything that I'm missing in the chat, just kind of last minute that we want to show people, or are we pretty much good to go here?
No, you've been doing great. I'm as puzzled by you about that crash that you saw. If you could send me that file that's crashing on Open, I'll see if I can figure anything out about it. Sorry about that. And no, we've been having a good conversation.
Great. So I see a lot of good stuff going on over here in the chat. I'll have a look at that while I'm on my break here. Again, this is kind of a notional model. I'm not going to release this particular version of it. I could. It might be easier to release, but since the OpenVSP representative UAM models are out for the Revolutionary Vertical Lift Technologies project, just go to the website and download that one. And then you can start from there and, see if you can do better. That's kind of what they're for. But that concludes our Tiltwing demo. I hope everybody enjoyed it. I hope it was informative. If you have questions, you're welcome to post anything either here in the chat or, as always, follow up with us on the OpenVSP Google group. We can post a link to that so that everybody knows where to go. But otherwise, we will see you all here in about half an hour.